welcome to our podcast and today's our guest is Niharika Patil. Welcome Niharika, please introduce yourself.
Thank you. Thank you for inviting me here today. And my name is Niharika Patil. I am third year student in Anasar Dani College of Engineering, Ashta, in the Department of AIDS. And today's our topic is vulnerability assessment in cloud computing. So we will now start with the podcast. I hope you guys will enjoy it. Please.
Okay, then what is cloud vulnerability assessment?
Okay, so in simple language, it's basically the process of going through everything your organization has running in the cloud and asking what cloud and what could an attacker break into and how badly you are finding the weak spots before the bad guys do. And I know that sounds simple, but here's what makes cloud specifically tricky compared to what we learn in like a traditional networking class. So in cloud, we are working under what's called a shared responsibility model. So AWS, Azure, Google Cloud, they take care of physical stuff and the actual data centers, the hardware, the underlying networks. That's their problem. But everything you build on top of that, your virtual machines, your databases, your storage, how your configuration, configure access, your application code, that's entirely on you. A lot of breaches don't even happen because some crazy sophisticated attack reports of complaints getting breached because they left a storage bucket, um, basically a folder in the cloud, wide open in the public internet. Anyone could just go in and download that data. No hacking needed. That's a misconfiguration, and vulnerability assessment is what catches stuff like that. So that's also this thing called configuration trip that I think is really important to understand. You spin up cloud resources really fast. That's kind of the whole point of cloud. But over time, as your team keeps moving, it keeps making changes, the security posture slowly gets worse without anyone noticing. So assessment can't be a one thing, it has to be an ongoing procedure.
So, what is actual threats? Like, what are the things you are trying to find out?
Okay, so I'll break it into five main categories based on what actually came up with like what is constantly happening. So like number one, and this is this big one which is misconfiguration. So Gartner report predicted that through 2025, 99% of cloud security failures would be the customer's fault, not the cloud providers. The most of that comes down to misconfiguration. So things like databases exposed in the internet, storage buckets set to public when they shouldn't be, and logging turned off in on critical services. So there's no trail. If something goes wrong, it sounds so avoidable. But when you are managing hundreds of clouds accounts with thousands of resources, it's genuinely hard to keep track of. And the number two, IAM issues. So IAM stands for Identity and Access Management. So basically, who is allowed to do what in your cloud environment? Think of it is like permissions on your laptop, but way more complex and way higher stakes. So, like in companies where people had admin access to everything when they only needed access to one specific service, or they were using the root account, the most powerful account for everybody's everyday task. That's like running your whole life logged in an administrator on Windows. If an attacker gets the credential, it's game over. They can move sideways across your entire cloud environment, like, and the number three, unpatched workloads. So your virtual machines and containers are running actual softwares, and that software has bugs. We call them CVEs, common vulnerability and exposures. So if you are not regularly patching them or scanning your container images before you deploy, You are basically leaving your known unlocked doors everywhere. So number four, insecure APIs. Cloud native apps are super API heavy, and if those APIs don't have proper authentication or input validation, they become attack vectors. I actually I actually saw a case study during my study, and where a company accidentally exposed an internal API to the public internet. So internal meaning it was never designed to be accessed from outside, and that was not a good way for that team, which caused actual losses. And so number five, supply chain risks. When your own code is solid, if your own even if your own code is solid, the open source libraries you are using in your serverless functions or containers might have vulnerabilities. And the SolarWinds attack, like the SolarWind attacks a few years ago, really woke everything up to this. Your security is only as strong as the weakest dependency in your stack.
Okay. So how do you actually run one of these assessments? Like, what's the process?
Okay, so the methodology I learned is that actually it maps pretty well to what NIST and other frameworks recommend. So breaking down into five phases, like phase one, scoping and asset discovery. This is honestly the phase that surprised me most. Before you can access anything, you have to know what you have. And in cloud environments, this is genuinely hard because of something called shadow IT. So, developers spinning up resources on their own without telling the security team. That is what it means. So, you start by using to tools to inventory everything, every virtual machine, every database, every storage bucket, and every cloud account, every region. And the phase two, threat modeling. This is where you ask who would actually attack us and what are they after. A university running a research project in the cloud, and that has like a very typical threat model than a bank. And what are the most sensitive assets? What would be the worst case scenario? This shapes everything else in the assessment. So, phase three, automated scanning. This is where the tools come in and do the heavy lifting. There are platforms called CSPM, so it means Cloud Security Posture Management tools that continuously scan your cloud configuration and flag things that are wrong. So, there are also vulnerability scanners that check what's running on your servers, and secrets scanning tools that look for things like API key accidentally committed to code repositories. By the way, happens way more than you would think, including by students. Please don't put your AWS case in public GitHub repos. I'm saying this to place, which is really important, because like we can say there are like AWS keys in the GitHub repos that can happen by students. And the phase four, manual validation and pen testing. So automated tools are great, but they produce false positives and miss man like the needed issues. So you always manually validate critical findings. And for important systems, you bring in penetration tester, basically an ethical hacker, to actually try to break in and see if they can chain together multiple smaller vulnerabilities to achieve something serious. So we can say that it is like thinking like the attacker, and it genuinely changes how you look at security. And then the phase five, which is risk prioritization and remediation. So you will find a lot of vulnerabilities, like a lot, and you can't fix everything at once. So you rank them by actual risks, not just technical severity, but business impact. It is this vulnerability on a public facing system? Does it touch sensitive data? How easy is it to exploit? Then you build a remediation plan. The most critical stuff gets fixed like in 24 to 72 hours. High risk within a week, and medium risk within a month.
Okay. What tools should we actually know about? Like what would look good on resume or be useful to learn?
Okay, so that is a very relevant question for us as students. And so, like starting with cloud native tools, meaning tools built into cloud platforms themselves. So, AWS has something called Security Hub, which pulls together findings from several other AWS security services into one dashboard. So, it's genuinely powerful. And if you are doing any AWS work, you should know it exists. Azure has Microsoft Defender for cloud, and Google has Security Command Center. These are baseline tools that every company using those platforms should have turned on, and many don't, which is why Wiz, it's a cloud security posture management platform that does this really cool thing where it builds a graph of your entire cloud environment and shows you attack paths. Like, here's how an attacker could start from this public exposure, hop through this misconfiguration, and reach your most sensitive database. Visualizing this that is incredibly powerful. Prisma Cloud by Palo Alto. By Palo Networks is another big one, especially for container security. There, these are enterprise tools with enterprise price tags, but they have students and trial vendors worth exploring. So for frameworks, and I would really encourage everyone to look at this as the CIS benchmarks are free, publicly available documents that give you specific hardening guidelines for AWS and Azure and other tools, like hundreds of concrete checks you should be making if you want to get into cloud security. Read the CIS benchmarks for whatever platform you're learning. And there's also like another tools for cloud matrix. It's a free framework that maps out all the techniques real attackers use against the cloud environments. It's basically a catalog of how attack happens. Studying that gives you the attacker's perspective and completely changes how you think about defense. And obviously, NIST and compliance frameworks like SOC2, ISO 27. You will encounter these in basically any security role. So it's worth being familiar with the concepts.
Okay. What are the mistakes you see people make, both at the companies and like students learning this stuff?
Okay, so the biggest one of the organization level is treating assessment as one-time checkbox instead of continuous practice. So companies do a scan, fix the critical stuffs before an audit, but audits can fix the critical stuff and then go back to ignoring it until next quarter. But cloud environment change constantly. New services are deployed, configured, so the new services get deployed, configuration drips, new CVEs get published every day. If you're not doing continuous assessment, your security posture is basically decaying in real time. Second, drowning in finding without context. A scanner might spit into A scanner might spit out 10,000 vulnerabilities. If you try to treat them all equally, your team burns out and nothing meaningful gets fixed. You have to ask which systems are actually important, which are customer facing, which store sensitive data. Context transforms a list of CVEs into actual prioritized action plan. Third, treating security as only the security team's problem. So, in reality, the developers are the ones who can actually fix vulnerabilities. If security findings never make it into the development workflow, like into their project management tools or sprint planning, nothing gets remediated. The best setups I saw had security findings automatically piped into their tickets assigned to the right engineering team. So, for students specifically putting credentials in code, I have to say it again. AWS access keys, API tokens, passwords, do not commit this into GitHub. There are bots that can scan public repositories constantly and will find and abuse your credentials within minutes. Use environment variables. Use secrets managers. Just please not hard coded in your code, and also underestimating containers and Kubernetes. So many programs teach you cloud security in high level, but don't go deep on container security. Kubernetes has its own attack surface and API servers. Network policies, pod permissions, and it needs specific assessment approaches. If you are into cloud security, learning Kubernetes security is genuinely a differentiator right now, because Kubernetes and containers are also like very important stuff you should learn.
Thank you guys. Hope you have enjoyed. And thank you Niharika. It was a very beneficial podcast, I think. Yes, thank you for inviting me here, and I hope you guys enjoyed it.